I'm Grigor. My team and I did the solar survey project, and my part of this was to make the survey GUI. So the first part that I did was where the user can select the trial. That would be morning, noon, or late afternoon. Then next, the user enters the current date and time. There's also a text box where the user can enter the COM port that their Arduino is connected to. And then there are start buttons for each test. So when you create a new location that you're taking a survey at, you enter a location name, click New, and then select where that location is. After that, you can start all of the trials. So when a trial is completed, I have code here that checks the status of each trial, and it updates these by turning certain sections green when they've been completed. So for example, if I select silo, where all of them have been completed, all of these are green. For the start load callback, which is the start button for the load sweep, it cycles through different resistance values on resistor 0 and records 256 data points. After recording the data points, it saves the file and then turns the background green to show that it was successful. For the start open callback, that is run when you click start under open circuit sweep, and it works in a similar way, except both resistors are set to 255. The select trial box is a group of radio buttons where only one can be selected at a time. And for that callback, I have it check the status of those trials and change the background to green, and it also updates the statuses for each sweep. Next, I have functions that check the status of each sweep, and that's when they're created. So if when the program is first opened and the selected location has all the trials completed, this will check for that and turn these green if they've been completed.
I'm Mary, and I will be talking about the survey GUI, which we created in order to store locations and data. And one of the first functions we have was a menu, and we created a menu which stored all the locations and displayed all the locations which have been stored in the GUI. And then as a part of that, there is a new button. And when you hit the new button, it will allow you to add a new location and just enter it in as a string. And then afterwards, when you hit the new button, the GUI will then hide all the rest of the information, whereas if you click on an existing location, it will show the trials completed and whether you completed the load sweep in open circuit or not. We also created a delete callback, which allows which allows you to select an existing location and then delete it. And after you delete the selected location, it will update the list box with the current locations. And then once again, when you hit the new button to add new data, then you can enter in a location name and click on the coordinates. A map will show up, and click on the coordinates where the location is located, and at the same time it will have green dots and a text to specify current locations.
I'm Nick Jens, and I'll be explaining how we did the GUI for task 2. And basically, if you look at the GUI, there's only 2 button groups, one with 4 options and one with 2, and a plot button. And pretty much, if you look at the coding, if you go back up to the beginning actually, there's if-else statements and else-if. That will read in what values that the user put in. So if they chose average, it'll make trial equal to 0. If they chose open circuit, it'll make choice equal to 0. So these if-else statements choose or they edit what trial is equal to and what choice is equal to. So if we move down, this area of the code just loads the map. So when you run it, it loads this map, the JPEG file in the background. So, and it shows it in figure 1. So if we continue on to the next if-else statements, and with the for loops and everything, it pretty much reads in the x and y coordinates of what the user input for all of the data from task 1. Pretty much it reads in the x and y coordinates, which is right here and here, and the voltage, which the Arduino read in. So, and each if-else block is for the different choices that the different combinations, I guess, that they could have inputted or in the GUI. So if they chose morning and open circuit, it would have plotted something different than if they chose this and that. So if we continue down the code, this section of the code it interpolates the missing values between the recorded points that we got from task 1. And contour, that's the function that we were told to use to plot. So it just creates these lines. So, and we pretty much had to use interpolate data so that we can fill in the blanks of the areas that we did not record at. So, and this part, the last part of the GUI, it just closes the picture and it. So if I close it, they both will close. So I'm going to show you really quickly how to use the GUI. Pretty much you use this box, this data box. You can just choose which data you want to plot. You can choose average, morning, noon, or late afternoon. And then in the second box, you can choose how to plot it, I guess. There's max power point or open circuit voltage. So if you look through it, you can plot, and it'll show that plot. And say we want to show this, the average and max power point. If you press plot, it'll show this. So that's pretty much it. Thank you.